Welcome to The Explainer. Today we're taking some seriously complex food science and translating it into a microscopic true crime mystery, one that's literally happening right inside your wine glass.
Picture a stunning, flawless pour of red wine. Looks perfect, right? Well, contrast that beautiful mental image with the shocking reality that millions of microscopic saboteurs, we're talking molds, yeasts, and volatile compounds, are constantly plotting to completely ruin it. It is an absolute microscopic battleground in there.
To organize our investigation today, let's quickly run through our suspect lineup. We're going to start by meeting the moldy culprits, then look at rogue yeasts acting as double agents, break down the complex science of cork taint, and wrap up by seeing exactly how winemakers preserve that perfect pour. Okay, part 1. Meet the moldy culprits. These are the fungi actively destroying your vintage.
So here's the mugshot for our primary suspect, Botrytis cinerea. In the agricultural world, they just call it gray rot. This particular fungus is absolutely ruthless. It aggressively targets and depletes the nitrogenous matter in the developing wine, basically starving the whole ecosystem of its essential building blocks.
And its crimes go way beyond just stealing nitrogen. It causes massive oxidative breakdown, and most devastatingly, it destroys anthocyanins. If you don't know, anthocyanins are exactly what give red wine that vibrant, rich color. So botrytis is literally draining the life and color right out of the wine until it's just this dull, totally unappetizing brownish sludge. Just awful.
But, botrytis rarely works alone. It's got two terrible accomplices. First up is penicillium, or green rot, which leaves a really distinct, gross, musty odor whenever it infects wooden containers. And then there's aspergillus, known as white rot. This one completely covers the grape in a filamentous, mealy mass. It can even trigger the synthesis of ochratoxin A, which is a toxin that's legitimately harmful to human health. So yeah, bad news all around.
All right, moving right along to section 2, yeasts, the double agents.
Now, yeasts are obviously necessary to ferment wine, but they can flip and go rogue on you in a heartbeat. Take Zygosaccharomyces baeyi. This guy is an almost unstoppable villain. It causes unwanted refermentation directly in the vat or even in the bottle. It creates all this turbidity and trapped carbon dioxide, and it literally laughs in the face of very low pH levels, high alcohol content, and standard preservatives. It is so ridiculously resilient that it might actually pop the cork right out of a bottle sitting on your shelf. Then we have Brettanomyces, which commits some highly specific, deeply bizarre sensory crimes. This strain synthesizes compounds called tetrahydropyridines and volatile phenols. And the result? Well, it can actually make a super sophisticated, expensive wine smell exactly like horse sweat, or a wet mouse, or wet leather, or burnt beans. I mean, seriously, definitely not the tasting notes you want to read on a label, right? And the physical changes are just as gross. Contaminant yeasts can ruin a wine by forming what winemakers call floor. It usually starts as these isolated fuzzy patches just floating on the surface of the wine. But eventually, they group together to create this extremely thick, suffocating film over the liquid, which completely throws off the delicate chemical balance underneath. Now, real quick, I should clarify something. There's a huge difference between contaminant floor and beneficial floor yeasts. Winemakers actually cultivate certain floor yeasts on purpose because they provide microbiological protection and add a really wonderful bouquet to specific wines. But contaminant floor, that stuff just degrades the ethanol into acetaldehyde. It leaves the wine tasting incredibly bland and completely exposed to even more microbial growth. Oh, and we absolutely can't forget the ominously named killer yeast, Hanseiniaspora uvarum. It absolutely earns that nickname because it actively inhibits the good fermenting yeasts. It totally takes over the unfermented grape juice, hoarding all the nutrients for itself, and commits the ultimate crime of leaving this sour, ester-like taste. It basically makes your nice wine smell exactly like liquid glue. No thank you. Let's dive into section 3. The science of cork taint. This is the ultimate chemical sabotage. We need to set the record straight right off the bat. Cork taint is not just finding crumbly little pieces of cork floating in your glass. Not at all. It's a profound organoleptic alteration, meaning it severely hijacks the taste and smell, and it originates deep inside the cork stopper itself. It's caused by highly volatile contaminant compounds, mostly one known as TCA, that come in and completely mask the wine's natural, delicate aromas. The way this crime unfolds is actually a fascinating, albeit destructive, biochemical chain reaction. First, filamentous fungi naturally living in the cork encounter a chemical called TCP. Now, TCP is toxic to them, so the fungi fight back. To defend themselves, they essentially sweat out an enzyme called CPOMT. That enzyme grabs the toxic TCP and transforms it into TCA. The fungi then secrete this brand new TCA, which gets immediately absorbed right into the porous cork material, just waiting to meet your wine. And what does that actually mean for your tasting experience? Well, when you pour a tainted bottle, you are not going to taste bright, beautiful fruit. Instead, your palate just gets violently assaulted by the undeniable flavor of a damp cellar, or wet cardboard, or rotting wood. It completely strips the wine of its consistency, leaving behind nothing but flat, rancid notes. It's a real tragedy. And the craziest part? These volatile compounds are unbelievably potent. They have staggeringly low perception thresholds. When we analyze the data for these chemicals, we are literally measuring them in nanograms per liter. The human nose is just remarkably, almost annoyingly sensitive to these specific chemical signatures. To put that insane number into perspective for you, it takes a mere 1.5 to 3 nanograms per liter of TCA to utterly ruin a wine. That is an almost imperceptibly small amount. We're talking roughly the equivalent of one single drop of water in an entire Olympic-sized swimming pool. Yet, that one drop is enough to completely destroy a bottle's carefully crafted flavor profile. Finally, Section 4, Preserving the Perfect Pour, and how winemakers fight back. Because winemakers are definitely not taking this line down. They deploy a seriously impressive arsenal of defense tactics. They create anaerobic atmospheres in the vats to literally choke out the molds. They add bentonite clay to the mix, which acts like a giant magnet for unwanted proteins and cuts down the need for sulfur dioxide. They even use charcoal, which is amazing because it can actively pull bad aromas right out of the liquid. Add in high-tech UV light lamps and microbe-proof filtration systems, and they do a pretty incredible job of keeping those rogue film-forming yeasts completely at bay. So it's a delicate, completely microscopic balancing act all the way from the vineyard down to your glass. The next time you pop open a beautiful vintage red or a super crisp white, and you get hit with the startling smell of a wet dog or damp cardboard or liquid glue, well, you gotta ask yourself, which of these microscopic villains are you gonna blame? Thanks so much for joining me on this explainer today. Until next time, keep learning and always trust your palate.